Derivative as a limit. So we should get the limit definition for derivative out here. There's two of them, but in this case, we can see that h is going to 0. So for the h going to 0 case, it would be the limit as h goes to 0 of g sub t plus h minus g sub t, and we have h on the bottom. All right, so we can kind of see that's the case right here because we're going to 0 and we do have h on the bottom, so it's fitting that case. Which derivative is described by the following expression? Okay, and then we're trying to analyze what's being kind of said here to help us out. Now, for me, the key is we can kind of look at this minus sign right here, and then that really helps to separate what g sub t plus h is. So if we look at it, that means that this right here is your g sub t plus h, where t is your point that we're going towards or that we're kind of focused on. So in this case, we can kind of see that we have a square root function, we have the number 9, and we have the plus h. So g sub t plus h is equal to this. And that tells us that we can kind of see what our t is, what our h is, and what our function is. Of course, h is h. So that means our g function, or they're using f. I'll go ahead and let's go ahead and change that. Let's use f now. I want it to link together. So we're seeing our answers for f is equal to, well, what number is it that we're plugging in here? What t is it right there? Well, it's the 9 right there. So f of 9 is equal to, and then here's our function on the outside. It's equal to the square root function. And then what do we have inside of here? We just have, it would be all kind of included together. It would just be the x. The x is kind of everything that's inside of here. And then we can always kind of link together and make sure and confirm it. So notice that we have a g sub t right here. So if I plugged in 9 into this function, do I get 3 out? And yes, we do. So that just helps to confirm that's our answer. So in this case, and don't forget, it's we're talking about a derivative. No, sorry. We're talking about our function right here. So there's our function right here, f of x. And then this is where we're talking about f prime of 9. So there's our number that's getting plugged in for t. We're talking about a derivative using the limit definition of this function. Okay. Let's go ahead and check on the next one. Which of the following is equal to f prime of pi over 2 for f of x sine of x? And then as we look here, we can see that now we have x going to a value. So as always, we want to write down our foundation. The foundation is the limit as x goes to t of g sub x minus g sub t. And then on the bottom, we have x minus t. All right, this one's a little bit easier to kind of recognize. This is basically our slope formula, where we have y2 minus y1 over x2 minus x1. Okay, so which one of these kind of fits these models that we have here? Okay, so notice they're trying to trick us with like the last model t plus h kind of setup. But so we just have our g sub x. So I would say the limit, I just like plugging it in. That's kind of the easiest way. And we'll see which one matches. G sub x would be our f of x, so that'd be sine. And x is x. Minus sine is our function, sine of t. T is the value that we're plugging in here, so that's our t value. So sine of pi over 2. All over, we still keep our x minus, and our t value is pi over 2. Okay, so which one of these matches that? We got Oh, and then our t, our t in this case is pi over 2. All right, so as x goes to pi over 2, this would give us the derivative or the slope at any point, in this case at the pi over 2 point. Limit as x goes to pi over 2 of sine of x minus sine of pi over 2, x minus pi over 2. So everything kind of links together there. So my advice would be to use the definition just to fit what they give you into the definition, and then you can match it that way. A lot of these answers, at least for me, kind of throw me off. Easy to kind of confuse you. Let's take a look at the next one. That's that one there. And this looks like the very similar type of problem. Let's go ahead and attack it. But okay, we're asked which what derivative is described by the following expression. So once again, recognize that x is going somewhere, so always kind of practice it. The more you practice it, easier it is to memorize. So limit as x goes to t of g sub x minus g sub t over x minus t. Okay. Excuse me. And let's go ahead and analyze what we got here. So in this case, we can kind of see what our function is. This in this spot tells us what our function is. So that means this is our function here. Right there is our function. And then this is our t, or our value. It should also match right here. So notice that we have a pi here and a pi there. So that's everything that we need. So this is telling us that our f prime of pi for, or where, our function f of x is what? It's just our sine of x. All right. So let's just go ahead and kind of match that. And f prime of pi, yep, there it is right there. See if the next one's any different. And it looks like the same kind of structure of a problem. Sure, let's go ahead and just do one more. So this is, once again, notice that we got the h going to 0. So the limit as h goes to 0 of g sub t plus h minus g sub t all over h. All right, notice we got all over h right here. This right here, I think, is kind of the key. This helps us to recognize what the function is. And then this is actually plugging in a value. So that means that if I were to do this, it would be the limit as h goes to 0. Our function is e to the x, so that would be e, and then t plus h. And then just kind of remind yourself in this case, that is your t right there, your value. So that's going to be an e, and that's going to be an e right there inside there. So it's going to be e to the e plus h minus e, the function with that value, e to the e, all over h. All right, do any of those match? And is that it right there? It. How are the, oh yeah, just be careful. It's not an X, it's an E, right? They're they're switching it all up. So just be very careful about these. It's easy to kind of flip it. So it's not that one. It's not the X value getting plugged in, or it's not the X variable, not the X variable. And how are these different? E to the E. All right, I almost picked it. So notice that's missing that E to the E right there. So that's not it. So it's this one right here. So be careful. The more similar they are, the more careful you have to become. Okay, so that should give you a good start on trying to handle these.